Okay, welcome to Physics 101 class, Mechanics and Properties of Matter. Today we're looking at Chapter 1, Systems of Measurements, Physics 101. And we have three systems of measurement in physics. We have the CGS, we have the FPS, and we have the MKS. The CGS represents centimeter, gram, seconds. The FPS represents foot, pound, seconds. And the MKS represents meter, kilogram, seconds. Now, when we first started studying physics, we have only three quantities. The first three quantities in physics were length, mass, and time. The first three quantities in physics were length, mass, and time. That's why we have just 3 units for them. So in the CGS system, length was measured in centimeter, mass was measured in grams, time was measured in seconds. In the FPS system, length was measured in foot, mass was measured in pounds, time was measured in seconds. And in the MKS system, length was measured in meter, mass was measured in kilogram, time was measured in seconds. Now, among these three systems of measurement, the most accepted system of measurement was the MKS, whereby length measured in meter, mass measured in kilogram, time measured in seconds. So while solving in physics, and you have to calculate time, if your time is given in minutes or hours, always tend to convert to seconds. If your mass is given in grams or pounds, always try to convert to kilogram. If your length is given in centimeter or foot, always try to convert to meter, because meter is the most universally accepted system of measurement. And in your exam, you could be asked that which of the following system of measurements is the most universally accepted? Is the MKS. So after this, other quantities in physics were later discovered. Apart from length, mass, and time, we now had other quantities in physics, and we term them physical quantities. Physical quantities. So our next topic we want to look at now is physical what? Quantities. And under physical quantities, our physical quantities in physics can be broadly divided into two. The physical quantities in physics can be broadly divided into two. We have fundamental quantities and we have derived quantities. So when looking at the physical quantities in physics, we have fundamental and we have derived. We have fundamental quantities and derived quantities. So all quantities in physics can be broadly divided into two, fundamental and derived. Fundamental and what? Derived. Class. So as the study of physics progressed, we moved on from just length, mass, and time to other quantities. Several other quantities were now discovered. So we had to group them as all under physical quantities. That means the quantities of physics are called physics, from the word physics, physical quantities. And the physical quantities can be broadly divided into two. We have fundamental quantities and derived quantities. Don't forget this chapter 1 of Physics 101, and the heading is systems of measurement. That's measurement system. That's the chapter 1 of Physics 101. So we want to arrange the courses in your head, because many students are complaining that the thing is scattered. Some people don't even know what's chapter 2 in Physics, what's chapter 3. We're just letting it scatteredly. So they want to arrange it from chapter 1 to chapter 2 to chapter 3 till the end, like that. So moving forward, we have fundamental and derived quantities. Actually, we have 7 fundamental quantities. We have 7 fundamental quantities. And what are fundamental quantities? We say fundamental quantities are the quantities from which all other quantities are what? Are derived or obtained. So we call fundamental quantities, large, you can write, are the quantities from which every other quantity in physics are what? Are obtained. So they are the source quantities. You can call them the source. They are the source or the foundation of all quantities we have in physics. The fundamental quantities are the source or foundation of all quantities we have in physics. Fundamental quantities are the source or foundation of all quantities we have in physics. Because why do we call them the source or foundation? Because from these quantities, every other quantity emanates from the fundamental quantity. And there are 7 in number. The fundamental quantities are 7 in number. Class, amongst the 7, we have already listed 3, which are the 3 oldest quantities in physics. We have listed 3, which are the 3 oldest quantities in what? Physics, which are length, right? Mass, time, temperature, length, mass, time, temperature, electric current, we have amount of substance, amount of substance, and the last one we have what we call luminous intensity, luminous intensity. Class, as simple as this is, you could be asked in the exam, which of this is not a fundamental quantity? So we have 7 fundamental quantities: length, mass, time, temperature, electric current, amount of substance, luminous intensity. Write down. Now, any quantity that is not listed here is derived. Any quantity that is not listed here is what? Derived. So, all other quantities in physics, class, why are we studying this first chapter 1 of physics? Because this is from this chapter 1 that we have all the foundations in physics, class. Every possible question they can ask you in physics comes from quantities. Comes from what? Every possible question they can ask you in physics comes from quantities. In your exam, if you ask to calculate force is a quantity. Any question they ask in physics is one quantity or the other they're asking you. Right? Calculate the acceleration, quantity. Calculate the density on the substance, quantity. Calculate the speed, quantity. Calculate the pressure. Calculate the power acting on the body, quantity. Calculate the work done. Calculate the Young modulus of elasticity, quantity. So everything you ever have in physics comes from this foundation. So if you get this foundation right, you're already on your way to understanding physics. Now continue. So every other quantity here is what? Derived. Let's look at density is derived. Area is derived. Velocity is derived. Velocity or speed. You can call it velocity or speed. They mean the same thing. Velocity of speed measures how fast the body is moving. Acceleration is derived. Acceleration is what? Is derived. Where force is derived. They are so much. They are so what? But class, all these guys are fundamental. They are not derived. That means they are the ones that started physics. They are the quantities that we use to start learning physics. So they were not derived from anywhere. They were originally what? Understood. Now, class, these are quantities. Don't look at physical quantities, right? But it's what we call physical units. Just like we have studied physical quantities, we also have what we call physical what? Units. Class. You cannot talk about quantities without talking about units, class. Because units give expression to quantities. Units give expression to what? Quantities. So why quantities are what we've just studied now? Class, every quantity in physics has a unit. Every quantity in physics has a unit. Class, without units, quantities will not be understood properly. Because if someone tells you, what is the mass of a body? And you say 500. Class, 500 does not make sense until you say 500 kilograms. If someone tells you, what is the time taken to move from point A to point B, and you say 200. Class, 200 does not make sense until you say 200 seconds. Until you say 200. So you see how units come into the picture. So units gives what? Identity to the quantities. Class, I can say something now, and without mentioning the quantity, you will know what I'm talking about. If I say 300 meters, what am I talking about? Length. I'm talking about what? Length. 300 meters, I'm talking about. If I say 50 Kelvin, what I'm talking about? Temperature. Without saying temperature, because you get Kelvin, right? You know there's temperature. So you see what units do. So for every quantity, there's a unit. It means that if we have physical quantities can vary into fundamental and derived, right? Also, physical units can be divided into fundamental and divided into fundamental and derived. So just like we have fundamental quantities and derived quantities, we have fundamental units and derived units. Class, each of these 7 fundamental quantities have their fundamental units. Have their what? The unit of length is meter. The unit of mass is kilogram. Unit of time is seconds. Temperature is Kelvin, please, and not degree Kelvin. There was a question they asked in the exam, and instead of Kelvin, they put degree Kelvin. The answer was 5. But option A, they put 5 degree Kelvin. Option B, they put something else, maybe 10 degrees Celsius. Option C, 20 degrees Celsius. Option D, they now put 5 Kelvin. 5. Now, because someone is rushing, someone might not easily see that this one is carrying degree, this one is not carrying degree. So you solve. After getting 5, you are so happy. You now rush for A. You just saw 5. Meanwhile, the correct answer is 5, but it's 5 Kelvin. There's nothing like degree Kelvin. There's nothing like degree. So please, when solving your exam, look at the options carefully. Look at the options carefully. Now, electric current, the unit for electric current is ampere. Unit for amount of substance is moles. Amount of substance measured in what? Moles. Luminous intensity is measured in candela. Candela. Luminous intensity is measured in candela. Candela. Class. Now, having understood fundamental and derived quantities, the next thing you are supposed to learn on chapter 1 is called dimensional analysis. Dimensional what? So let us go to dimensional analysis. Class, dimensional analysis is an approach or a method of returning the fundamental quantities back to returning the derived quantities back to their fundamental forms. Dimensional analysis. Dimensional analysis Dimensional analysis is a method of what? Taking the derived quantities and returning them back to their fundamental form of mass, length, and time. Class, what do we do in dimensional analysis? It's an approach or a method of taking the derived quantities and returning them back to their fundamental form of mass, length, and time. We use M to represent mass, L to represent length, and T to represent time. If you notice in dimensional analysis, we are taking the first 3 that were discovered, which I told you. The first 3 quantities in physics were mass, length, and time. Class, what we do is this. We said that all derived quantities are gotten from the fundamental quantities, right? All derived quantities are obtained from the fundamental quantities. We said that all derived quantities are obtained from the fundamental quantities. So what we do in dimensional analysis is to return the derived quantity back to their fundamental form. How do we do that? Class, pay attention to this aspect because this will form the foundation of everything you will be doing in physics. Because in this aspect, you'll be learning different formulas. A very good physics student should have a repertoire of formulas, different formulas, accumulation of different formulas that will stand you in good stead for any questions that may come your way. So any question that is thrown to you, you have a formula to attack it because you studied very well. Because in dimension analysis, you cannot solve dimensions without what? First knowing the formula. You cannot solve dimension of a quantity without knowing the what? Formula. For example, let's look at the first formula, area. If we are asked to find the dimension of area, you must first write down the formula of area. So dimension analysis forces you to know formulas. And if you know formulas, you can solve any question in physics, right? Because every question in physics depends on one formula or the... So if you know formulas, you can solve any question in physics. This is where most students' foundation starts from. Problems start from. Because in the exam, they say calculate the momentum. You don't know the formula for momentum and you are lost. Calculate the coefficient of friction. You don't know the formula for coefficient of friction and you are... Calculate the coefficient of viscosity. Calculate the Young modulus. Calculate the moment of inertia. Because you do not know the formula, you are stuck. Any question you are stuck in physics is because of a formula you don't know. But this area of physics helps you to deal with formulas because if I want to get dimension for any quantity, I must write down the formula first. So in this area, I'll be looking at several quantities and their formulas. And they are... So area is length times breadth, class. That's the formula. So first step to find dimension of the quantity is to write down the formula. After writing down the formula, don't forget we're working with MLT. We are returning the formula back to ML, meaning that any part of the formula that has to do with mass, replace it with M. Any part of the formula that has to do with distance covered, replace with L. Any part of the formula that has to do with time taken, replace with what? T. Any part of the formula that has to do with mass, M. Any part of the formula that has to do with distance, L. Time, T. Looking at this formula, both length and breadth are a function of distance. Just different names, right? Length, breadth, they are still distance. So it means that these two will replace L and L. That is L times. And what's L times L? So the dimension for area is L squared. And the unit is meter squared. So class, L squared is the dimension. The unit is meter squared. Because this length is measured in meter. And we have length squared. Meter will also be squared. Are we together? We have just gotten a dimension and the unit for area. If we go to volume, volume is length times breadth times height. Volume is length times breadth times height. Class, both length, breadth, and height are still talking about distance. Just different name, right? So, both length, breadth, and height are L times, giving you L raised to power. Class, this is the dimension for volume. L raised to power 3. And if this is the dimension, the unit will be what? Meter raised to power. Because each length is measured in meter. So if we have length in 3 places, meter will also be in 3 places. Class, we are still in the simple examples. The challenge now lies when they give you a quantity that you don't know the formula, what will you do? Everybody knows the formula for area. Everybody knows the formula for volume. What if they give you a quantity that you don't know the formula? And without the formula, you cannot get the dimension. That's where the challenge will start. Don't forget, anytime I find the dimension, I also find the units. Now, class, let us go to density. Don't forget, the first step in finding dimension of a quantity is to write down the formula first. Density is mass all over. So this aspect of physics is teaching you formulas which you need for exam's sake. Don't forget, we're working with MLT. What's mass? Is it not M? And thank God we just did volume, right? What was the dimension for volume? L raised to power. So the dimension for density is M all over L raised to power 3. Class, this L raised to power 3, when it comes up, what happens? It takes a negative sign. And it becomes ML raised to power minus 3. ML raised to power minus 3. This is the dimension for density. If this is dimension, what is B unit for density? Mass measured in kilogram. Mass is in what? Meter. Length is in meter. But whatever happens to length, it also happens to the unit. Meter raised to power minus. Since the length was raised to power minus 3, the unit meter will also be raised to power what? Minus 3. So kgm raised to power minus 3. Class, are we following? This is the dimension for density. Mass over volume. But mass is M. Volume is L raised to power 3. So that when L raised to power 3 comes up, it acquires a negative sign and becomes L raised to power minus 3. Class, moving forward. Let us look at the dimension for speed or velocity. We'll do speed and velocity together because they mean the same thing. They have the same dimension. Speed velocity is distance or displacement all over time, right? Distance or what? displacement all over time. Distance or displace. Why do you say distance? Distance is for speed, displacement is for velocity. The difference between speed and velocity is that speed is a scalar quantity, velocity is a vector quantity. So speed, a scalar quantity is a quantity that has magnitude but no direction. A vector quantity is a quantity that has no magnitude, that has magnitude and direction. That has magnitude and what? Direction. A scalar quantity has only magnitude, no direction. A scalar quantity has only magnitude, no, but a vector quantity has both magnitude and what? Direction. So both speed and velocity is a measure of how fast the body is moving. But speed measures how fast the body is moving without direction. Velocity measures how fast the body is moving with, thank you. So whether it's distance or displacement, distance is a scalar quantity, displacement is a vector class. They are both L, right? Because they are talking about distance. Time is what? T. So dimension for speed or velocity is L all over T. Class, can this T come up? When this T comes up, it takes a negative sign, LT raised to power minus 1. Dimension for speed or velocity, LT raised to power minus 1. Class, the next thing we'll look at is acceleration. Class, notice that it is only derived quantities that we are studying their dimensions. We are not studying the dimension for fundamental quantities because they are already in the dimension already. So any quantity I'm listing here are all derived. Remember that when we started, we said we have fundamental and derived quantities. And I listed 7 fundamental quantities. I did not list any derived quantity. Why? Because I knew that when we come to dimension analysis, we'll talk about all the derived. Good. Acceleration is velocity all over time. If you are in this class, it means that you are starting your physics on chapter 1, which will be organized in your head. So it's not scattered. You're in chapter 4. You came one class, chapter 5. You came one class, chapter 7. Everything just scattered in your head. Now we are arranging it from the beginning, right? Inside your. So velocity all over time is the formula for acceleration. Class, we just did velocity, right? Velocity is LT raised to power minus 1. We just did it. It's still up here. Now all over time, time is T again. Time is what? So LT raised to power minus 1 all over T. Class, when this T, we also want to come up and join this T. Therefore, making this LT raised to power minus 2. So this will turn to from T minus 1 to T minus 2. Why? Because of this T below. Class, because of this T below. You know why I keep looking at this mic? Once this mic stops, the battery of this mic is dead. I'll do the video myself. It will not be playing. No voice. So please, someone should help me. You see this green light? Once it stops, let me know. Let me. So that I can detach that thing from under the phone. Then you can listen to my normal voice. But if this thing goes off and that thing is still under the phone there, I will not be hearing what the video is saying. You see, that's why you see me going to go and check. Because if you not suffer do video, you're not going. Sometimes you go and play. The thing is not playing. That time at 120 I did on Saturday. After all the suffering, it was not even. I was not hearing what I was saying. So I could not upload the assignment. So I did not send the assignment. It was not playing. You will not hear what I'm. So this green light must be on. That's why I charged it to the full before I came to class. So you see the effort. There's a lot of work. This online class, you have to charge it. This ring light. So this inverter, you have to charge it. A lot of work. But if we have done it, we have done it. We have done it for the semester. When you enjoy these videos, the exam period, when you just need to be in your house to be revising, and you have all the videos, chapter 1 to the end, physics, math, chemistry, you will thank God I suffered to do this video now. So you, at your space, you just be studying at your, for an example, you don't need someone to rush you. Chapter 1, understand, take past question, solve. Chapter 2, understand, take past question. Like that, yes. So class, we've looked at speed, we've looked at acceleration. Let us look at force. Dimension for force. Force is mass times acceleration. Class, don't forget we're working with MLT. But thank God we've just finished doing acceleration, right? And mass is what? M. Acceleration, what do we just do acceleration? LT raised to minus. That noise they are making outside. Without this mic, it will have been entering the video and people will not enjoy the class. Without this mic now, all those noise outside, they will be entering the video. But with this mic now, only my voice is in the video. You brought the second one, right? The second one is there. So I want this one die. I'll put the second one. You didn't see it. Okay, I'll go and check. Now, Force is mass times acceleration. And mass is m. Acceleration, we just finished doing acceleration, right? And what do we get as acceleration? LT minus 2. So that force is mLT minus, what's the units? Kg. What is length? Meter. Time. Seconds raised to power minus 2. Why is second raised to power minus 2? Because time t is raised to power minus 2. Class, are we following? I know I'm doing video, but I still want to make sure that everybody in class is still following. I don't want to be too fast because I'm doing video. You're following? Good. Now, let us go to work. Work done. Work done. So if you are fully registered for this class, please send me your email. Send me your email. Drop it on our paid group. If you have registered fully for this class, that means you're on our paid group. Don't send it to my DM because too many. Imagine all our registered students sent to my DM. I will have too many messages to reply. Drop it on our paid group. I've seen everybody that has dropped so far. So that because some of these videos will only be accessible to our private students. What I will do, I will post this particular video for everybody. So that at least those that are online that are still doubting, they can see the quality of the video and see what we are doing for them. Then after this one, I won't post for anybody again. So this will be the last video that will be posted for general everybody. Yes. Now, work done. So please, if you've registered fully, you send me your Gmail. So any video I do, every day I'll be coming to school, whether we have class, I'll be coming every day. Any video I do, I'll do it like this. Make sure it's very clear. You see, I'm checking. I don't just video, I'll check if it's clear. If my voice coming out, check, do it very well. Any video I do, chapter 1, mathematics, differentiation, you have it in your Gmail. Only you can access it. Only you'll be able to access it. I won't post it on a general YouTube. I will put it in my YouTube, but you cannot see it if I don't give you access. There's some videos in my, if you go to my channel, there's some videos there that you are not seeing. Those are not, I've taught different sets. Those are not all my videos. But it's only those that have registered with me in that set that access those videos. That can access any video I post. If I want to post something, I was not doing it frequently like this. I did not buy ring light and all these things for it like this. But sometimes I used to post videos I will not allow anybody to access. Especially exam period. So there's some videos on that, my YouTube channel that you are not seeing. If you go to my channel, you will never see it. Normal eyes will not see it. Until I send you an email, an invite. It's a function in YouTube. I have to invite you via your email. So only those that have registered, you send me your email, I will invite you to see the video. You cannot even show your friend, you cannot show any, just you, only you can see it. It's private. It's a function on YouTube. Now, work done. So please, if you've registered, you have access to that. But this particular video will be free for everybody. Work done is force times distance. Force times. Force is mLT minus 2. And distance is what? L. Class, I know that force is mLT minus 2. We just finished doing it, right? Look at it. Force mLT minus 2. And distance is what? L. Can we multiply now? This L and this L gives you L square, right? That's mL square T minus 2. mL square T minus 2. And class, the unit is kg meter square per second square. Kg meter square per second square. That's the dimension for work done. Class, the general unit for work done, if you don't want to use kg meter per second square, you can say joules. You can say what? Joules. Also, this force, you can say Newton. You can say what? The general unit, Newton. You can use the general unit of what? Newton. Newton. Good. Class, the next function, quantity you want to look at is power. Power equals to force times distance all over time. Or what is force times distance? Work done all over. So power is work done all over time. Thank God we just finished doing work done. And what is work done? M L square T minus 2 all over T. All over what? T. Class, what will happen? Let this T come up. This T will do what? When this T comes up, class, there's already a T minus 2 here. When this T comes up, we also acquire a negative sign. So from T minus 2, we are going to have T minus 3. So we're going to have ML squared T minus. So it's a rule in mathematics. It's a rule in mathematics. When anytime a function goes up, it acquires a negative sign. But there's already a minus 2t here. So when this t comes and joins this 2, it now becomes minus 3. So we have negative t 3. Negative t what? 3. Power. Now, what is the unit for power? Class, mass is measured in kilogram. Length is in meter, that's meter squared. Time is in seconds. Second raised per minus 3. Or we'll just say watt. General unit is what? Power is measured in watts. Watts. 5 watts, 10 watts, 20 watts. Class, moving on, we have pressure. The dimension for pressure, you must first write the formula, is force. Pressure is force all over area. But force is mLT minus 2. Area is L squared. Force is mLT minus 2. Area is L. Class, L can cancel one L here, leaving one L down, right? Because we have one L up, we have two L's down. So when one L cancels one L here, another L will still be remaining because there are two down. Now this L that is remaining down can come up and take a negative sign. M is already up. L will come up, take a negative sign, become L minus. Then this T minus 2. Dimension for what? Pressure. Unit for pressure is kg per meter per second square. Or general unit for pressure. If you don't want to use this, what's the general unit for pressure? You can say Pascal. We can say Pascal. Like I'll be using this class. Now, class, moving forward. So far, we have been doing simple quantities that you can easily know the dimensions. I want us to now go to difficult quantities that dimensions are not easily known. There are some quantities that you cannot easily get their dimensions. Why? Because their formula is not common. Their formula is not. Number one of that such quantity is someone like, if they say find the dimension of surface tension. Apart from if you have been in my class before, normally, most year one students will not know the formula for surface tension in the exam. Surface tension is force all over length. The formula for surface tension is coefficient. This is called surface tension coefficient. This is a symbol, gamma symbol. It's force all over length. Once you know the formula, it's easy to get the dimension. But if they give you a quantity that don't know the formula, that's where the problem starts. Force is mLT minus 2. Then all over L. Are you seeing the advantage of starting a course from the beginning? Arrange, organize in your head, right? Step by. L, force all over L. 2 is a constant. We don't consider 2 when solving dimensions. Numbers like 2, 3, they are negligible when doing dimensions. You understand? Now, can this L cancel this L? Yes. What are we left with? M T raised to minus 2. This dimension of surface tension coefficient, that's kg. Units is kg per second square. Kg per second square. Kg per second square. Good. Kg per second square. Class, another uncommon quantity is moment of inertia. Most 100 level students might not immediately know the formula of moment of inertia. Even if they will get it, the time to take it to say, if they say force, mass translation, you know it fast, right? Some people will think before they get, even if they will get it. Some will not get it eventually. Some will pick a wrong formula. Moment of inertia is mass times radius square. Mass times radius. You see that once the formula comes, that dimension is easy, but the formula is the formula. If you don't know the formula, what will you? Mass times radius square, which is mass is m. Class, radius, is it m, l, or t? Radius, l, right? Radius is a function of distance, so it's l. You cannot say radius is mass. You cannot say radius is time, so it's definitely l, distance, right? You know radius now. Half the diameter of the circle is radius, right? So moment of inertia is ml square. We are looking at the unit. The unit is kg per kg meter square. Kg what? Meter square. Let us look at gravitational constant G. Gravitational class. You could be asked to find the dimension of gravitational constant G. The dimension of gravitational constant G cannot be obtained if you don't understand where the formula came from. The dimension for gravitational constant G cannot be determined if you do not understand where the formula came. The gravitational constant G is from the formula Newton's law of gravitation, which tells us that the gravitational force of attraction between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance r. This r stands for distance between two masses. Class, if you have two masses, m1 and m2, and there's a distance between them, r, there's a r distance between them, there's a gravitational force of attraction between these two masses called F. Now, the relationship between this force and these two masses, m1 and m2, and the distance between them, r, is given by this formula. F equals to g m1 m2 over r squared. Over r. Class, let us now make g subject of the, if you cross multiply and put this one, you're going to have g m1 m2. Class, another thing you should note, sometimes when the masses are equal, m1 equals to m2, we can call it m, since they have the same mass. So instead of m1, m2 is m times m, and m times m is m square. M what? So F can be equal to gm square over r square when the two masses are the same. Class, we only call it m1, m2 when to differentiate that they are different, to show that they are, when they are the same, we just say m, and m times m gives us m. So instead of gm1, m2 over r square, we have gm square all over r. Now let us make G subject of the formula. Why do you want to make G subject of the formula? We're looking for the dimension of G. And to get the dimension of G, we must know the formula of G. So let us make G subject of the cross. So that Gm square equals to Fr square. Dividing both sides by m squared so that we can make G subject of the G equals to Fr square over m. So the formula, once you know the formula, you can now go ahead to get the dimension. We have just gotten the formula for gravitational constant G. Let us now go ahead to get the dimension. I'll rewrite the formula here. So G has been gotten as what? F R square all over m. Don't forget that F represents your force, R represents the distance between the two masses, and m represents the mass. Class, we've gotten dimension of force before. Force is ml t minus 2. Go back to your note, you see it. We did it before, right? R means distance, L square, all over mass, m square. Can m cancel one m here? Leaving us with one m here. L times L square, L raised to power 3. So we left with L raised to power 3, T raised to power minus 2 all over. Can this m come up? When this m comes up, it takes a negative and becomes m minus. What do we have up already? L raised to power 3, T raised to power minus 2. Class, this is dimension for gravitational constant G. And therefore the unit will be K per kg, as kg raised to power minus 1. For mass is kg, right? For minus 1. L is meter raised to power 3. Because L is raised to power, and time is seconds raised to power minus 2. Class, this is how you get the dimension for gravitational constant G. These are not popular quantities that you use every day. Class, we can also be asked to find the dimension for pressure gradient. Pressure what? Pressure gradient. Class, anytime you hear any quantity gradient, means that quantity divided by length. Pressure gradient means pressure all over length. Pressure all over what? Length. Class, have we done dimension for pressure before? Yes. Can someone remind me what is the dimension for pressure? Please check your notes. ml minus 1, yes. T minus 2. So this pressure is ml minus 1, T minus 2. All over length is L, right? Class, can this L minus 1 cancel L? No. Because they are not the same thing. One is minus 1, one is just L. What can happen is that this L can come and join this L up to become L minus 2. T raised by minus 2. So L will come and join this L up and also require a negative sign. So from minus 1, L will now become minus 2. Because there's another L that has come up now. This is the dimension for pressure gradient. This is dimension for what? Pressure gradient. Class, another thing we should take note of is, next thing we want to look at now is dimensionless quantities. Write down. Dimensionless quantities. Yes, you have a question? Your modulus will come there. Dimensionless quantities. Dimensionless quantities are quantities whose dimension is 1. Class, there are some quantities that when you solve for their dimension, your final answer will be 1. Those quantities are termed to be what? Dimensionless. Those quantities are said to be dimensionless. There are quantities whose dimension is 1. Today won't go well. No hiccup. And it's very clear. Very, very clear. On Saturday, we're having serious challenges. My phone storage was just getting feed anyhow. I will do videos more. The thing will say storage full, storage full. I had to go and wipe out all my videos. Dimensionless quantities are quantities whose dimension equals to what? 1. In the exam, you could be which of the following quantities is not dimensionless? Which of the following quantities is not? So dimensionless quantities are quantities dimension. We must know the ones that are dimensionless. 1. Example of dimensionless quantities. Please write down. Example of dimensionless quantities. Class, don't forget, dimensionless quantities are quantities that if you find their dimension, your answer will be 1. You will not have ml this, L this. Your answer, final answer will be what? 1. They are termed dimensionless quantities. Dimensionless quantities. Number 1, example, first example, we have mechanical advantage is dimensionless. Mechanical advantage of a machine. 2, we have velocity ratio. 3, we have coefficient of friction is dimensionless. 4, we have tensile strain. Tensile strain. Class, all these quantities are dimensionless. All these quantities are dimensionless. Meaning that when you solve for their dimension, your final answer will be what? Will be 1. When you solve for their dimension, your final answer will be 1. Class, let's go ahead to prove it. Let's go ahead to prove that all these quantities have a dimension of what? 1. Let us show that the dimension gives us what? 1. We'll start with mechanical advantage. Class, from our secondary school knowledge, we all know that mechanical advantage is load all over effort. All over what? And class, whether you're talking about load or effort, they are both forces. They are both what? Class, in a machine, we have load and effort. To understand mechanical advantage, you must understand machine. And to even make it more interesting, machine is a topic in one of your scheme of work for physics, chapter 5, work, energy, and power. Class, a machine is a device that utilizes little effort to overcome maximum load. A machine takes your small effort to overcome a big load. Class, you have effort of just 200 Newton. Ideally, a 200 Newton effort cannot overcome a load of 500 Newton. It's not possible. It's not ideally. But class, a machine uses your little effort to overcome a big load. What allows you to use a small effort to overcome a big load is the mechanical advantage of the machine. Is a mechanical what? That's why it's called an advantage, because the machine gives you an edge. And mathematically, that advantage can be expressed as load divided by the effort. Now, both the load and effort are measured in Newton. And anybody that measures in Newton, it means you are a force. Because the general unit for a force is Newton, right? Meaning that the dimension for load is dimension of force, MLT minus 2. And dimension for effort is just dimension of force, MLT minus. Have we done force before? Yes. Dimension of force is MLT minus 2, MLT minus 2. So that when MLT minus 2 cancels MLT minus 2, the answer is just 1. Is what? When numerator and denominator are the same, if you say 5 divided by 5, is it not 1? 10 divided by 10, is it not 1? So MLT minus 2 divided by MLT minus 2 is what? And this proves to us that mechanical advantage is dimensionless. This is what shows that mechanical advantage is dimensionless. Are you for this class? Okay. Now, second one, we have velocity ratio. Velocity. So we have just dealt with mechanical advantage. Don't forget, we're looking at dimensionless quantities. Dimensionless quantities. Please, I hope my video is still recording. Still recording? Thank God. Today is a good day. Velocity ratio is also a machine concept or terminology. Plus, you can see that I'm teaching this course without any book, because I understand the course. I read this course myself. I made an A in this course in my 100 level. Are we together? So I always say you can't give what you don't have. It's one thing for someone that did not offer the course, you just know it. But this one, I did the course as a student. So I've passed through the student phase and the teacher phase as well. That's why I'm well grounded in the course and I can break it down to your understanding. Now, velocity ratio class is the distance moved by the effort divided by the distance moved by the load of a machine. Class, in order to carry a load, you cover a distance. Class, if I want to go and move that inverter, I'll cover a. So the distance moved by my effort to carry this inverter, this distance moved by the effort. Now when I carry the inverter is the load. I now move the load to a particular distance. That means the load has also covered the distance, right? So the distance moved by the effort to go and leave the load. And when you leave the load, you move a distance as well, right? So there are two concepts in machine. Distance moved by the effort and distance moved by the. Now, so that the ratio of the distance moved by the effort to distance moved by the load is called velocity. I mean the teaching machine in a way. That is the beginning part. Now, whether you are distance moved by effort or you are distance moved by load, distance is still distance, right? In dimension terms, what do we call distance? L. What do we call distance? L divided by L. You can see why the dimension of velocity ratio is also 1. You can see why the dimension of velocity ratio is also 1. We keep going. We keep making progress. The next one is coefficient of friction. Coefficient of what? Friction. Plus, the coefficient of friction is the ratio between two forces. The reaction force and the frictional force. Class, as a matter of fact, the frictional force acting on the body is directly proportional to the reaction force. Or the reaction force is proportional to the frictional force. And the constant that comes in is the coefficient of friction. Now, whether you are frictional force or your reaction force, force is still. So class, in physics, as long as you are called force, no matter the name before the force, mechanical force, this one force, as long as your name is force, you have the same dimension. So class, whether frictional reaction force or frictional force, force is still force. That's ML minus 2 all over ML minus 2. So when they cancel out, it gives us what? 1. So dimension for coefficient of friction is also 1. And the last one for dimensionless quantities is tensile strain. Tensile strain. The tensile strain is a term used in elasticity. Are you seeing that dimension is making us go to different topics in physics? We have taught machine. You see that I thought this is the foundation. You will know different formulas because of dimension. Dimension will allow you, enable you to know different. We have taught elasticity, machine, Newton's law of gravitation. That one we did gravitational constant, surface tension. It's taking you to different parts. It's building your foundation in physics. So any formula they ask you, you know formulas. So note the formula. See, any dimension we do, we first write the formulas down, right? Tensile strain is extension all over length. Extension all over. Class, both extension and length are a function of distance. They're a function of what? Extension is class. If someone was in elasticity, a body's initial length is L1, 10 centimeter. You now extended it, and the new length L2 is now 20 centimeter. Now, what is the extension? Extension is the new length minus the old. 20 minus 10 is still 10 centimeter, right? So extension is still a function of length because measured in centimeter. Measured in what? So class, extension, the dimension of extension is still L, and original length of the material before you extended it. So tensile strain is extension all over original length. But before a body is extended, it has the initial length, right? After extension, a new length is achieved, right? So whether it's the extension or original length, it's still L all over. L cancels L, giving us 1. And we have proven all the 4 dimensionless quantities that the dimension is what? 1. Next thing we want to look at, if you are done right, is quantities with similar dimensions. Quantities with similar. You have a question? Yes, but not. That's coefficient of static friction is the type of coefficient of friction. Because we have coefficient of static. We have 2 types of friction. We have static and dynamic. Static friction is friction of a body at rest. Dynamic friction is friction of a body in motion, also called kinetic friction. Do you understand? Because for a body to even be at rest, friction plays a role. Or for a body in motion, friction plays a. So we have static friction and we have dynamic. Class. Quantities with similar dimension. In the exam, which the following quantities have the same? First example, quantities with similar dimension. Our next subheading is quantities with similar dimensions. Quantities with similar dimensions. Number 1, we have momentum and impulse. Momentum and what? Number 2, we have work done and energy. Work done and what? Number 3, we have Young modulus. Young stress and pressure. And what? Young modulus, stress and pressure. They have the same dimension. Number 4, I've already told you some about speed and velocity, right? Speed and have the same dimension. Number 5, frequency and velocity gradient. Frequency and what? And velocity gradients. Have the same dimension. Frequency and velocity gradient. Class, we have already done speed and velocity, right? When we said distance or displacement all over time. You even see that those that have attended our chapter 1 before, you're learning it in a different way now. See, knowledge is vast. So I know when I first said, let's start on chapter 1, people must have been discouraged. I've already gone to chapter 4 now, so I continue for where we stop. But see that you're learning something new because I'm now doing, I even noticed that this online class is making me organize the class step by step. Because I know that I'm being recorded, so I'm being very careful in the teaching step by. So it's also favoring you. Now, So we have done speed and velocity. Let us look at momentum and impulse. How do they have the same dimension? Momentum. The momentum symbol is P, and the formula is mass times velocity. Momentum symbol is what? P, and the formula is what? What is mass? M. What is velocity? LT minus 1. LT minus, we've done velocity before now. We got LT minus 1. Someone show me check this. Am I still being recorded? It's still recording? Thank God. Now, impulse. Why do we say momentum and impulse have the same dimension? Look at the formula. What is the formula for impulse? Force times time. Force times. Look at the two different quantities with two different formulas, but they have the same dimension. Watch. What is force? We've done force before. ML T minus 2. What's time? T. What's time what? This T means T raised to power. So this is now ML. Class, T raised to minus 2 times T raised to power 1. What does law of indices tell us? Product law. When two quantities have the same base, pick one of the base T and add up the power minus 2 plus. So if you pick one T out of the two T's, then add up the minus 2 plus. This will be ML. Minus 2 plus 1 is minus MLT minus 1. MLT minus 1. Are you saying that impulse and momentum have the same dimension? You can see that impulse and momentum have the same dimension. No. Class. So we have ticked off momentum and impulse. Let us show work done on energy. I will use any type of energy. I will use potential or kinetic. Let me use potential energies. Class, work done. We have done work done before, remember. Who can remind me the dimension for work done? Force times distance, right? And force is ML T minus 2. Distance is L. So that L times L. ML squared T minus 2. Dimension for work done. Dimension for work. Now, let us look at potential energy. Potential energy, PE, is mass times acceleration due to gravity times height, mgh. Mg, kinetic energy is what? Half mv squared. But I told you, when doing dimension, numbers like 1 over 2, 2, 4, they are negligible. They are what? So I can clean this. So someone should not say, sir, but the formula is half mv squared. Yes, the formula is still correct, but when doing dimension, numbers can be cleaned off. So class, I want to prove that both potential kinetic energy and work done have the same dimension. As long as your energy, you have the same dimension of work done, you even have the same unit, joules. Let's look at that mgh, potential energy, mgh. M is mass, right? M. G is acceleration due to gravity. But class, acceleration is acceleration, whether you are due to gravity or not. Just like force is force, just like force is. So what is the dimension for acceleration, whether you are due to gravity or not? LT minus 2. We have done it before, right? As the dimension for acceleration is LT minus 2. And H, height is what? L. Height is what? Because anything that has to do with distance, L. What is L times L? ML squared T minus 2. Class, this dimension for potential. Is it the same we work done? It's the same we work. Kinetic energy is mv squared. Of course, it's half mv squared, we know, right? But we have removed the half because half is negligible. Now, mv squared. Kinetic, m is mass. V is velocity all squared. So what's velocity? LT minus 1. We have done velocity before, right? Now, all dimension of velocity is LT minus 1. But you now square it because it's LT minus V squared. So LT minus 1 squared. So we're going to have M. This square affects everybody in the bracket. L squared. T minus 1 times 2. T minus 2. ML squared. T minus 2. The same thing with potential. The same thing with work done. Same with potential. Same with work done. Now, we are proving work done on energy. Both potential and kinetic. Next one is your modulus. Class has the same dimension with stress and pressure. Your modulus is stress all over strain. All over what? Class, tensile strain, is it new to you? No. I think I've shown you the dimension of tensile strain. Where did I show you the dimension of tensile strain? Dimensionless, 1, right? So tensile strain is one of the dimensionless quantities. Tensile strain is one of the dimensionless quantities. So the dimension of tensile strain is 1. And class, stress is same dimension with pressure. Class, it means stress means pressure, but elastic pressure. Class, the pressure exerted on an elastic material is called the stress. The pressure exerted on an elastic material is called the what? Stress. So class, stress is pressure. So have we done pressure before? What's the dimension for pressure? Check your notes. We've done pressure before. ML minus 1, right? T minus 2. Strain is what? 1. So ML minus 1, T minus 2 divided by 1 is TML minus 1, T minus 2. Because strain is what? 1. So dimension for your modulus is same thing as stress, is same thing as pressure. Dimension for your modulus, same thing as stress, same thing as pressure. We've done speed and velocity. The last one is frequency and velocity gradient. The last one is frequency and what? Velocity gradient. Class, frequency is inverse of period T. Frequency F is inverse of period what? And period T, as long as you are dealing with time, period is under time. If you want to find the dimension for period, period is a time function, it's a time. So class, this T represents time. So T comes up and becomes T raised per minus. Class, dimension for frequency is T raised per minus 1. The dimension for frequency is T raised per minus. Because in physics, frequency is inverse of period, 1 over T. In physics, frequency is inverse of what? 1 over. So when this T comes up, it takes a negative and becomes T raised per minus 1. How is it the same dimension with velocity gradient? Class, velocity gradient means velocity all over length. Velocity gradient means what? And what's velocity, class? LT minus 1. All over. Can L cancel L? What's left? T raised per minus. Is it the same thing with frequency? Yes. This proves that frequency and velocity gradient means the same thing. Class, the last quantity they can ask you is what we call coefficient of viscosity. You could be asked to find the dimension for coefficient of. This one is just JAMB. I'm just giving you bonus here. Coefficient of viscosity is force times distance all over area times velocity. Force times distance all over area times coefficient of viscosity. Force times distance all over area times velocity. Class, I believe that once you are given the formula, to get the dimension should be very easy. Because we know the dimension for force is MLT minus, distance is L, right? Area is L, and velocity is LT minus 1. And velocity is LT minus. So it's just to do the math. And we're going to have L times L squared T minus 2 all over L squared times L raised to power 3, T minus 1. I'll come again in case you are lost. Force is MLT minus 2. Distance is L. Area is L squared. Velocity is LT minus 1. L times L on top here gives you L squared. So we have ML squared T minus 2. On below here, L squared times L gives you L raised to power 3, T minus 1. Class, L squared can kill L squared here. Only one L will be remaining here. Class, T minus 1 can kill 1 T minus 1 here. Under T minus 1 will still be remaining. Because T minus 2 means that there are T minus 1 occurring twice up. Who is now left after all the cancellation? We have M on top. We have T minus 1 on top. All over, down, we have just L. We have just what? When this L comes up, it acquires a negative sign and becomes ML raised to power minus 1, T raised to power minus, dimension for coefficient of viscosity. Dimension for coefficient of viscosity. This is the unit. It has a Snell symbol. Finally, they could give you a question that you can't use normal dimension method to solve. Class, remember that examples are usually very simple till exam kicks in. I have a question I'll give us here that will require a bit of a care must be taken to answer it. Class, we have word problems on dimension analysis. Word problems on dimension analysis. Word problems, yes. I'll give you an example. The resonance frequency, you can write this question down. The resonance frequency of a closed air column is known to depend on the pressure P, density rho, we have a symbol for density, it's called rho, and length L. How are these quantities related? How are these quantities related? I'm writing on the board so that those that are following us online, if I'm too fast in dictating, they can write down. The resonance frequency of a closed air column, the resonance frequency of a closed air column is known to depend on the pressure P, density rho, this symbol stands for rho, the symbol for density is rho, and length L. How are these quantities related? Class, it is dimensional analysis that helps us to know how these quantities are related. It is dimensional analysis that helps us to know how these quantities are related. Class, how do we use dimensional analysis to solve this kind of question? You see that example, someone must have left this class, I know these things in my area, and missed this last part. Now, even if you know how to find dimension for area, length times breadth, how can you solve this? There's a different method of solving this kind of dimension. There's a different method of solving this kind of dimensions. Class, we are asked to show how these quantities are related. The resonance frequency, let us call it F. Let's call it what? Class, I want to interpret this question mathematically. So solution now. Follow me, please. The resonance frequency F of a closed air column is known to depend. When you say someone is depend, it means it's proportional. It's known to depend means it's what? Proportional to the pressure P, density rho, and length L. This is how you interpret this question. They say one quantity is known to depend. How do you write known to depend? Proportional sign. Proportional is proportional to the pressure P, density rho, and length L. How are these quantities related? Class, dimension analysis can help us to, they're asking you to form a formula between frequency and these three quantities. They're asking you to form a formula between frequency and these three. Class, this frequency is known to depend on these three, right? It means that these three are independent. Why this frequency is dependent? This frequency is what? So this frequency is dependent on these three. So this frequency is a dependent quantity. Why these three are in the class? For the independent quantities, they are the ones that will determine how the formula will go. So ascribe unknown powers to them. These are you solve. Ascribe unknown powers. Let this be x, let this be y, let this be. Because it's those powers that will know how these quantities are related. It's with the powers we use to know how the quantities are related. So step one in solving questions like this, ascribe unknown powers to the independent quantities. Who are the independent quantities? The quantities on this side. This guy is dependent. The question said it, that the resonant frequency of a closed air column is known to depend. So this guy is dependent. Don't give this guy unknown power. It's this guy that will determine how this guy is dependent on them. So ascribe unknown powers X, Y, Z. You can use A, B, C. You can use alpha, beta, gamma. You can use any letter you like. After ascribing unknown powers, class, in mathematics, every proportionality sign can be changed to equal to sign when a constant is introduced, right? Kp raised to power x, density. Remember, don't confuse P with rho. This pressure, this density, density raised to power y, length raised to power z. For class, the dimension of a constant is negligible. You can claim it's just like 1. Constant can be maybe 2 or half. For example, you know those something like half mv squared. That constant might be 1/2. So they are negligible. So we can claim this k. So what we're actually working with is f equals to what? P raised to power x, density raised to power y, and L raised to power z. This k is the constant, right? Now, class, when we have gotten the value of x, y, and z, we'll come and put it into this. This is the final answer to our question. We just need to go and get x, y, and this is how the quantities are related. This is the formula. But we need x, y, and z. Once we've gotten x, y, and z, we have shown how these quantities are related. How do we get x, y, and z? Class, we are going to convert each quantity in this formula back to their fundamental forms. We're going to change each quantity in this formula back to their fundamental. Class, resonance frequency, whether it's resonance frequency or normal, frequency is frequency. Frequency is what? Just like force is force, acceleration is acceleration. Have we done dimension for frequency in this class? Yes. When we did frequency and velocity gradient, right? What was the dimension for frequency? T raised per minus, thank you, minus 1. Because frequency is inverse of period t, right? Frequency is 1 all over t. When t comes up, it takes a negative, good. Becomes t raised per minus 1. Class, are we together? Now, K is dimensionless, it has gone, right? Pressure, P. Have we done pressure before? What's the dimension for pressure? ML raised to power minus 1, T minus 2. But pressure was raised to power what? X. Pressure raised to power what? So dimension, everything must be raised to power X. Have we done density before? Density is ML raised to power minus 3. Check. Density is mass all over volume. Volume is LQ. When LQ comes up, it becomes L minus 3. Please go back and check. We have done density before. And density is raised to power what? Y. L is length. L is already this dimension. L raised to power Z. L raised to power what? Z. What did we just do, class? We converted each of these quantities back to their dimensions. Haven't done that. Let us expand where necessary. Because we have brackets here, we have brackets here. Let's expand. Let's expatiate. On the left-hand side, we just have t raised to power minus 1 equals to, can m take x? Can L minus 1 also take x? Minus 1 times x minus x. L minus. I'm using x to expand the bracket, to go through everybody in the bracket. Because x belongs to everybody in the. Can minus 2 take x? Minus 2 times x. Minus 2. Are we following, class? Let me come one more time if I was too fast. Can m take x? M raised per x. Can L minus 1 take x? Minus 1 times x minus x. Minus 1x, which is minus x, right? T minus 2 times x minus 2. Let's y also open this bracket. Can m take y? M raised per. Can minus 3 take y? Minus 3. And L raised per z. Class, we have L scattered. Let's collect item. We also have M and M scattered. Class, on the left-hand side, don't say that we have only T. We don't have M and L on the left hand. So, class, let's introduce M as M raised per 0. Because anything raised per 0 is still. Let's introduce L on this side to L raised per. So we can balance both sides. Because this side cannot have only T, and this side has M, L, and T represented. Class, M raised per 0 is 1. It doesn't affect our equation. Anything raised per 0 is. So it doesn't affect our equation. I'm introducing m and l as m raised per 0, l raised per 0. Then t raised per what? Minus 1 equals to, in case you are tired, the video is there. You can go and watch it again. Now this m, let's collect all the m raised per x times m raised per y. Pick one m out of the powers x plus. Pick one m out of the power x plus. Are we following, class? Pick one m. We have two m's. Pick one m and out of their powers x plus. How many l's do we have? 3 l's. Pick one l, add up all the powers minus x plus minus 3y, which is minus 3y, plus times minus is minus, right? Plus, we pick one l out of these 3 l's, right? And add up their powers minus x minus 3y plus. How many t's do we have? Just one t. T raised to minus 2x. Class, can you read this kind of thing in textbook and understand? It's not possible. Let's be honest. Some things needs to be taught. Some things needs to be what? So when someone says, I'm going for lecture, are you not going for tutorial? No. Can you read things like this? Thank God we are videoing it. Someone that came late now can go and watch it, right? If you didn't video it now, you say, I missed this thing or I came late. But now, there's a video for you. You can go and watch it. Class, you see the advantage of putting m and l on this side? Because what we're going to do next is that we're going to equate m on this side to m on this side, l on this side to l on this side, and t on this side to t on this. It's called equating equivalent parameters. It's called what? Equating equivalent parameters. Equating equivalent. Remember that before we do not have m and l on this side. So it was smart to introduce m and l as m raised per 0, l raised per. So we're going to equate m on the left hand side, which is m raised per 0, to m on the right hand side, m raised per x plus. Equate l on the left hand side, l raised per 0, to l on the right hand side, l raised per minus x minus 3y plus. And equate t on the left hand side, t raised per minus 1, to t on the right hand side, t raised per minus 2. Thank God, though. Class, I will now solve these 3 equations to get x, y, and z. The genesis and revelation of everything here is to get x, y, and the reason for everything we are doing here is to get, once you get x, y, and z, we'll put it inside here, and this will now show how the quantities are related. Because the question said, how are these quantities related? Class, who is the easiest to solve among these 3? The person that has only one unknown, x, is the easiest person to. Class, in this equation, t is on the left hand side, t is on the right side. T can cancel. So that minus 1 equals to minus 2x. So that what? Because we have t here, we have t here. T can cancel t. And minus 1 equals to minus 2. This is what they have taught in chapter 1. That some students don't even know that they have taught it. Some people just resume. They don't even know that they have taught something like this. And they are just lost. So imagine the exam, they're not going to see something like this. They will be shocked. And lecturer will never tell you that he has taught it. He will just keep teaching and finish. He will go. He will never come for makeup. You will never hear lecturer doing makeup. So let's start our chapter from chapter 1, chapter 2. Mathematics are also chapter 1, chapter 2. I read it in your head. Physics, chemistry, like that. Every day I'll be coming to teach, record, so that everybody can access the class. So minus 1 equals to minus 2x. Minus can cancel. So that 1 equals to 2. Divide both side by. What's x? We've gotten our first unknown. 1 over. If we get x now, who is the next person that is easiest to solve among these 2? M, right? Because M has 2 unknowns, right? This is the hardest because it has 3 unknowns. Plus, in this side, can M cancel M? So 0 equals to x plus y, or x plus y equals to x plus y equals to, let's do it here. X plus y equals to, that's after M has cancelled M, x plus y equals to, who is x? Do we have x now? X is 1 over 2. Look at x here. X is 1 over, we solve for x from this side, right? And we got x as 1 over, so 1 over 2 plus y equals to, let y remain here, but 1 over 2 moves to this and becomes minus 1 over, we now have x and y. Y is minus 1 over 2. X is 1 over 2. Y is minus 1 over, we can now go and get z. Because we have x and y now. We have only one unknown now, right? L cancels. Let us solve for this here. So minus x minus 3y plus z, right? Equals to 0. What's x? What's y? plus z equals to minus 1 over 2 minus 3 times minus 1 plus 3 over plus z equals to, let's find the LCM. The LCM is 2 in 2. 1 times minus 1. 2 into 1, 1 plus 3 plus z equals to minus 3 plus minus 1 plus 3 is plus 2 is what? Plus minus 1 plus 3 is plus 2. 2 divided by 2, 1. So we have 1 plus z equals to, can 1 come to this side? So that z equals to minus, so that z equals to minus 1. Class, haven't gotten the unknown x, y, and z. Input it into this main place, and you have gotten how these quantities are related. Except you are taught this kind of thing, you can't get it in the exam. Because I'm not sure they taught something like this in secondary school exactly like this. It's not possible. They will. That's why they can rewind it now. They can rewind it and watch again. You know, it's not something that you have watched, you can never see it again. You can rewind and watch. Oh, what did you do here? You can pause. Look, what did they do? Once you pause now, the whole board will be on you now. You cannot check what you want to check. Right? You can just pause and say, okay, okay. Because if it's playing, to be moving forward. But if you pause it, you can say, sir, okay, okay, you understand? Videos you can play several times till you get what we did now. It's still accessible to you. It's even you here that is physical class that might not be, because you cannot watch, you cannot do it, so you go and check the video. But someone in the video now can say, okay, what? Okay, go back. Oh, it now came here. Oh, okay, continue. You see? Okay. Class, I don't expect you to understand from the first example. It's not possible. It's not. More examples makes it more. Practice makes. You see why I said, let me go back chapter 1. Imagine you have wasted time to that 4. Meanwhile, you don't know what's hiding in chapter 1 for you. Now imagine chapter 2. Chapter 2 has what we call differentiation and integration. I think what am I even do? Throughout this week, from Monday to Saturday, I will cover everything in physics. I recorded. Everything in physics. Next week, I will see it as a project for me. So tomorrow, I'm coming for chapter 2. I'm Muslim chapter 1. Tomorrow, I'm coming for chapter. If you are free, still come. So you learn chapter 2. Next tomorrow, Wednesday, I will do chapter 3. Thursday, chapter 4. Friday, chapter 5. Saturday, chapter 6 and 7 and 8. Since Friday is more time. Friday, 6, 7, 8. This course has only 10 chapters. If I've done 8 out of 10, it means that next week is just 2 remaining and I'm done with physics. I'll take chemistry, demystify chapter 1, dissect the math, dissect the other math, the. So only you now, you can just take video and say, I'll finish this my math in 1 week. I have all the videos, I've paid. Revise. Before you know it, you are done. It's your syllabus. So please, if you have not registered for this class, kindly do so, because these videos won't be accessible to everybody. I've said this several times. It won't be accessible to every. But this first one, I will upload for everybody so they can see what they are, the quality of what we are giving them. I'm happy that this thing came out very well. Sound is very well. There's no noise, background noise. There's a mic, so there's no background noise, so you can follow the class. You can pause if you are tired, pause, sleep, wake up, continue. Like some of you in physical class, you are sleeping now. If there was no video, you are finished. Right? But online class now, you can watch, sleep off, wake up. Where did I stop? Continue. As you're taking more questions, you'll be getting better. As you're taking more questions, you'll be getting. A sphere of radius r. A sphere. A what? Of radius r. Moving with velocity v through a fluid. Through a what? Experiences a retarding force. A retarding force F given by F equals to 6R raised to power Y, V raised to power Z, and coefficient of friction raised to power X. So a coefficient of viscosity, this symbol stands for viscosity. Where N is viscosity, R is radius, V is velocity. Find X, Y, and Z. Find the values of X, Y, and Z. Find the values of X, Y, and Z. Class, this one, they have already given us the mathematical expression, so it's easier than the example I gave. In my example, they did not even give us that F is equal, we are doing that derive this, right? They said the resonant frequency is known to depend on the pressure P, density rho, and length L. So we now wrote down the mathematical expression, right? But in this one, they're giving us mathematical expression. Just start solving. Just start solving. Class, a sphere of radius r moving with velocity v through a fluid experiences a retarding force F given by F equals to 6R raised to power Y, V raised to power Z, N raised to power X. Class, this 6 is a constant, it's negligible, right? What would you first? Convert each component of these quantities to their fundamental forms. What's F? ML T minus 2 equals to what's radius? L raised to power Y. What's velocity V? LT raised to power minus 1 raised to power Z. What's coefficient of viscosity? We have done it in this class. Viscosity is M L raised to power minus 1 T raised to power minus 1. Confirm, please. Please confirm for me, class. Correct? Good, good. I just converted each of them to their dimensions, to their what? But 6, you know why 6 is no longer there, right? It's a constant, it's negligible, it's negligible. Haven't done that. What do we do now? We expand the class. In this particular question, we don't need to put M raised to power 0, L raised to power 0, like we did in the former question, right? Because M is already in the question, L and T is complete. So when it's not complete, anyone that is not complete, put raised to power 0. But this one is already complete, so we just start solving. M L T minus 2 equals L raised to power Y. Let's use this bracket to expand. This Z will come to everybody. L Z, right? T minus 1 times Z. T minus Z. M L T will expand X. So M raised to power X, not minus X, now X. M raised to power X. L raised to power minus 1 times X minus 1 times X. T raised to power minus, collect like terms. This M L T minus 2 equals M raised to power X first. Where are all my L's? L, L, L. Add them together. L minus X. Let me start minus X plus Y plus. Pick one T and add up the power. Minus X minus Z. Minus X minus. What do we do next? Equate equivalent parameters. Equate what? Equating equivalent parameters. Equating equivalent parameters. I'm almost done with chapter 1, physics. Interesting. Chapter 1, physics. What do we mean by equation? M on this side to M on this. That's M raised to power X must be equal to M on the left hand side. This M raised to M must be equal to M. What's M? M raised to power 1. M raised to power X equals to M. What does M mean? Raised to power 1. What of L? L raised to power minus X plus Y plus Z equals to L raised to power 1. Because this L here means L raised to power T. T raised to power minus X minus Z equals to what's T here? Thank you very much. T raised to power minus 2. Class, can M cancel M? So that X equals to. Who is the next easiest person to solve this? Can T cancel T? So that minus X minus Z equals to minus 2. But who is X? 1. So minus 1 minus Z equals to minus. Can minus 1 go to this side? Minus Z equals to minus 2. When minus 1 comes, what does it come? Plus 1. Minus Z equals to minus 2 plus 1 minus. Can minus cancel minus? So that Z equals to. So X is 1, Z is Let's now come and solve this. L cancels L. So minus x plus y plus z equals to 1, right? If these two have cancelled, their power equals to each other, right? What's x? Minus 1. Replace x with 1, right? So instead of minus x, minus plus y. But with z equals to 1. Minus 1 plus y plus 1 equals to minus 1 plus 1. Cancel each other so that y equals to. So x is 1, z is 1, y is. And you have solved this question in the exam. And you have solved this question in the. Ladies and gentlemen, we are actually done with chapter 1, systems of measurements, physics 101. If you stay to the end of this class, you have completed your course, physics 101, chapter 1. Watch out for chapter 2. If you have not subscribed to our YouTube channel, click on the subscribe button so that, and register with us in the tutorials so that when chapter 2 comes up, you access it. I'm giving chapter 1 to everybody free so you can see what you are going to be expecting in the class, the quality class. You can see the quality of the class. Chapter 2 will also be like this. We will not reduce the quality. We have all the tools. So we're not going to reduce the quality. It's the same phone. It's the same everything. We are recording everything. The ring light, everything is here. So register with us so you can get all the classes. So thank you for staying with us to the end. If you have any questions, you can drop on the comment section in the YouTube page. Drop your questions. Sir, please, what did you do here? I will explain in the general online group. So that success online group we created is for us to explain everything you didn't understand in the video. After each video, you can come to the WhatsApp group or on the YouTube. You see comment section. Ask your questions and I will answer you. Thank you very much.